we got this 2017 Chevy Equinox. I think it's an Equinox with the engine failure due to the blown rear main seal, due to the Equinox all-wheel drive. Due to the frozen PCV system, customer obtained a used engine out of Winnipeg, and he was told that the supplier would send it somewhere and get the timing chain and guides replaced. Now it looks like it's been apart. It does look like it's been apart, but they cut the wiring harnesses. Look at this, they cut the O2 sensor when they could have just, they didn't even need to unplug it. Why did they cut that? Cut the wiring harnesses. Oh well. Have to look to see if there's any evidence of a water pump leak on this thing. Because this thing came out of 2012. Apparently from 11 to 17 it's the same basic engine. I see there's no converter on here, so that's good. Now, I don't know if I can remove this engine without, it's supposed to come out the bottom, but I know that on the two-wheel drive, front-wheel drive systems, you can pull the engine out the top. It only has to go forward about a ½ an inch to clear the flywheel. And there's more than enough room in front of the engine bay, in front of the crank, you know, between here and the frame to do that. But my concern is the all-wheel drive system is sitting right here, the transfer case is sitting right here, and it may interfere with this bolt or something. But we're going to have a look as we get ready to do this job. So you can see the amount of water in this air inlet line. Now this hose should be allowing fresh air into the valve cover, but what happens is, because the PCV blocks off, it starts flowing backwards in this direction with the high concentration of water in there. As you can see, it freezes in here because this is out in the open, and then once it's frozen in here and blocked at the other end, then the crankcase builds up pressure and it has to go someplace, and the weakest link is the rear main seal. It blows the rear seal out. Now what they could have done to enhance this or prevent this or lessen the likelihood of it happening is insulate this hose, at least cover it with sponge. More proactive would be to put a heating element around the hose, like a tracer wire that heats up when it's below freezing. Because if the PCV system freezes, which is apparently very common on these vehicles, and you don't realize it, you lose the engine oil out of the vehicle and destroy the engine, like what this one has. So I've removed the plastic trim with all the push pins on both sides, removed the air induction system and the air cleaner, the cosmetic cover over top of the engine. We're going to go in here and remove this bracket because we've got some bolts on the catalytic converter that we have to undo. Drain the cooling system. Looking at the front of the engine, there appears to be enough room for it to go forward. My only concern is that transmission. So I'm going to have a look at it from underneath. So remove the ECM connectors. You have to press this red lock release out, push down in the center here, and then unlatch the connectors. Remove the ECM. There's one bolt that holds it down, and then the whole ECM slides over to the left fender. Remove the battery tray. I like to bag and tag everything just in case it doesn't end up going back together. You never know what might happen. I'm going to maybe take this lower battery tray out. There's one bolt here and two bolts on the side down there. That'll give me better access to the bell housing bolts down there and the wiring and stuff. And the AC pipe is attached to the battery tray housing. Okay, let's continue. So I've disconnected all the electric plugs up top here. I took the brake bracket off here that holds the air induction system up, or the cosmetic cover, I think. Yeah, the cosmetic cover. And the shield off the manifold. Now I notice there's no O2 sensor in this manifold right there. So obviously they've changed the exhaust configuration, so we're going to have to use this exhaust manifold. which is fine. Probably best if I take it off right here, right now anyways. There are 3 fasteners, as you can see there. I'm going to spray them with penetrating fluid. We're going to heat them up. I haven't taken the fuel line off just in case I have to use the torches here, so I don't want to have any fuel vapor. Okay, I removed the lower rad hose to drain the cooling system. I don't like touching these plastic petcocks up here, even though this one's fairly new, because sometimes they break and then you got to change the entire rad. So got the starter out, battery cables disconnected, knock sensor unplugged, oil pressure sensor unplugged, but I can't get the crank sensor unplugged. The metal or the plastic lock broke. The secondary lock broke. Sometimes that happens. So I'm going to take the whole crank sensor out of the block, this little bolt here, and we're going to undo the AC compressor and hopefully set it on the frame here. I got yeah, we should be good. We're getting there. The AC compressor has 2 bolts and a stud, one down here, one at the very back there, and the stud at the top. Now that's nice because it won't fall down, but you got to move it, the compressor, like 6 inches this way or 5 inches this way to get it off the stud. So I'm going to remove the stud with a stud remover so that I can drop the compressor straight down. You can put a socket, 13/16 socket, 21 mil on the front of the crank, and turn the engine over until you access the bolts through the starter opening. They're 18 mil. There's 3 of them. Take them out. I see another challenge here. There's a brace on the front of the engine, bolted to the engine, that supports the end of the drive axle. And as you can see, it doesn't look like there's enough room for that bolt to come out of there without pulling the drive axle. And then there's another one up on top as well, right up there. Oh boy, said it was going to be easy. So if you take a brass drift, you can knock the axle shaft inboard or out towards the wheel, and you can get at this bolt now. So you won't have to take the axle out, but we'll have to make sure that that clips back in when we put the vehicle back together again. And this brace is going to be a challenge to line up. Maybe I'm going to unbolt it from the end of the transfer case here. So pull the engine wiring harness up. Now remember, it goes in down through here on the inside of the dipstick, and attaches its tie wrap to the dipstick. I'm going to pull the exhaust manifold off because I have to change it anyways, and it'll be easier to access those bolts and studs on the transfer case and the upper bell housing bolt too. Well, look at that. Another inherent problem with these things. The exhaust manifold's cracked, and I need to use this exhaust manifold. I'm not sure I can use the other one. I mean, I suppose it doesn't matter if it has an O2 sensor in it. I don't know if the other manifold's cracked. Well, it's not cracked. At least not in the same spot right here. Well, we'll have to compare it. I hope it's the same offset and same distance. Otherwise, we're going to have to replace the manifold. So there are 10 nuts that hold the exhaust manifold on, but it won't come out of there with the block heater in place. So there's a block heater here with a bolt holding it in place, and you need to remove that bolt at least ½ an inch in order to get the manifold to come off, because the block heater kind of goes over top of the manifold ear under there. Stupid design, but that's what it is. So here's a closer look at that manifold where it's cracked. They all cracked there for some reason. Well, because I guess heat and stress. And this ear here won't clear the block heater. You can actually see the crack in the inside of the manifold. So the manifold's off. We're going to compare it to the one that's on the used engine. Kind of looks the same except for the except for the O2 sensor bung, which is not drilled on this one. So we could either leave this sensor in here or put a plug in there. I have a plug. The manifold looks the same. 12672285, 12672283, 1260983. Kind of looks the same. It's got the same ears here, here, and here. Well, we have to, there you can see that block heater. It's over top of the manifold ear, so you have to undo that one bolt in there and get at it with a 10 mil. When you go to put it back on, start the block heater and leave it loose from the block about a half an inch. That bolt's pretty long, and it'll allow you to weasel the manifold in there without, because it's a little bit of a pain to get up there and redo that. Anyways, let's continue. Just a note, the 3 studs on the catalytic converter had removed with the nuts, fortunately. Otherwise you wouldn't be able to take the manifold off. You'd have to take the studs off or drop the crossover or drop the catalytic converter. It's rigid here, so the manifold won't go that way unless these studs came out, and they did. Now there's 2 bolts down below there. There's the one down there that I need to remove. Wow, this is not going to be convenient. You can't get at these bolts from underneath. There's too much stuff in the way between the power steering rack and the catalytic converter and the final drive. Wow. So I removed this bolt that holds the brace. It allows you to move it over. You can see that bolt up there on the bracket. And we have to take that stud out, so hopefully we can get this bolt out. It'd be nice if it comes out with the stud, because that stud, actually that just holds that bracket on there. There's another one up here. Oh, it's behind that. Oh, lovely. So that's got to come off anyways. Fortunately, that stud came out. So that also holds the final drive housing. I took the bracket off this end, so there's no bracket there now, so that's perfectly clear. As long as there's no dowel pins on this bracket here, you can push the exhaust up. Now that all bracket's out of the way, and you can push it, let it hang down, and you can get at those bolts pretty good. Yeah, that should be fine. Now there is one bell housing bolt way up there, way up inside there, right in the middle of the screen now. Hopefully you can get at it from the top. Got all these bottom bolts out, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 down the bottom. Oxygen sensor harness disconnected over here, so I should be able to pull that up. Yeah. So there's access to that upper bell housing bolt with a long extension, as you can see. 18 mil. So lower radios, harnesses off of the cam sensors, vacuum line to the brake booster, ground wire back here on this stud, O2 sensors unplugged, all the coils unplugged, coolant temp sensor unplugged. It's underneath this shield. I've got to disconnect some coolant hoses. There's this one here, and these 2 coolant hoses go to the overflow bottle here. Got all the bell housing bolts out. There's 2 on top at the back here. One with the ground cable under the thermostat housing. So it's pretty much ready to come out. I just got to figure out how I'm going to lift it, what I'm going to use to lift it. I use braided straps, but we'll see tomorrow. So I decided I would test lift this used engine first and get it prepped. I'm waiting for a helper. I removed the exhaust manifold, the block heater. I got to remove this stud. Removed all the bracketry and plumbing off the engine. I'm going to pull this intake manifold off and check that orifice, which means taking this fuel line off because it's in the way. Got to take this out, the dipstick support out. Going to change the oil filter while we're here. Put new oil in it. I'm going to change the flywheel. Now when you're in here at the flywheel, you want to make sure that both dowels are in the engine block, where you clean this surface so that there's no imperfections. The Roll-Lock sanding disc. Going to use the original flywheel just in case the teeth are in better shape, but I'll check it. As far as I can see, the cam sensors are the same. This engine has less kilometers on it, believe it or not, than the one that came out, so we're going to leave the spark plugs in there. And you can see that it's had the timing chain tensioner replaced. Probably the timing chain was supposed to be done. Yeah, so far so good. I used the alternator bracket bolt here, and there's a bolt here in the back of the cylinder head. This is a strap for pulling wires through conduit. Got it from a linesman. It works really well because there's no lift eyes, no lift hooks. It's probably a little low in the front, but this will be close enough to get the engine out. And we're going to do a couple more things here and then lift the engine out of the engine bay. So there's the back of the block all prepped. Intake manifold gasket area cleaned off. And I'm removing this intake manifold so we can check that PCV circuit. We're going to clean the throttle body as well while we have it off. But you need a fuel line disconnect tool here, such as this one here, to release the fuel line. There's no pressure in it, obviously. I can't do this with one hand, so I'm going to unbolt this bracket here so that this fuel line comes off. So once you take the dipstick bracket off, dipstick comes out, disconnect this bolt here that holds the wiring harness to the fuel rail, and remove the cosmetic or sound deadening and insulation cover off the intake. There's just 1, 2, 3, 4, 5, 6, 7, and I think there's a couple bolts on the bottom, maybe not. Okay, looks like there's just 7 bolts. So remove the 2 studs at the top of the intake manifold so that it can actually go down, because when it tries to come off it hits this pipe here, and I don't want to take the high pressure pump off. The end of the stud has a 5mm hex on it. So once you get the manifold off, you can see the PCV orifice, and here it is in the intake manifold. That little tiny hole is what causes the problem. If it plugs up, then the PCV system doesn't work, and then it starts to go backwards. In other words, the pressure in the crankcase starts to push air from the crankcase out of this vent and into the air cleaner, into the air induction system. Trouble is, there's a lot of condensation in that air, and it tends to freeze in this pipe, and then it freezes and it's plugged on both sides and it blows the rear seal out, and that's why we're here. So we're going to clean up this orifice and clean up that and put new gaskets on it and reinstall it. So there's the head surface prepped. I used a tip cleaner welding tip cleaner to clean that orifice, and made sure the passage through the block into the crankcase is open, and new gaskets in there. There's a gasket set, manifold set. I think I'm going to use his throttle body as original one because this one's off at 12. So I got the cherry picker in there, and then I realized there's a bolt right under the thermostat housing that goes in from the manifold side, I didn't see this one. That's why it's always nice to look at the engine here. See this, where this dowel is here? There's a bolt that goes in from here. I got this one, but that one I'll have to get from inside here. Wow. So it's on its way out. What you need to do though is support the right side of the transfer case with some blocks of wood like I have there, because the bell housing will tip down on this side. It'll fall down and then it won't be enough room. It's just barely enough room. You can see this crank pulley bolt is right up against the frame, and we got, mind you, the engine's twisted on this because I didn't secure it properly, so there's just enough room. So there's the engine out. I did have to undo the strut rod and then put a tie strap to open the hood up. You got quite a bit of space here. Just make sure you don't go too far. You'll hit the hinge, will hit the fender. If you had a helper, you could take the hood right off. I don't like taking the hood off because then there's a chance it'll get scratched or damaged. You can see the amount of oil in the back here. We're going to pull the flywheel off here and have a look at this rear seal. As I said, we're going to use this flywheel unless it's damaged. You'll notice the 3 holes. This one is quite big, quite large, and this one is oval. So you want to make sure that you start with that bolt hole over here, because that'll guarantee that the other 2 bolts will go in. So you can put this over here when you're putting it in, and then put that bolt in and torque it, and then turn it a third of a turn and put the next bolt, and so on. If you put one of these bolts in first, you might not be able to get this one at the end. Just a little tip. As I said, there's that bolt right there that goes in from the back side. It's hard to see. I managed to get it with the 1/4 inch or 3/8 electric impact gun and a swivel socket and extension. It's going to be a challenge putting it back in. This is angled a little bit too much. I'm going to make sure that the other one, when we go to put it in, is more level. But that's it. It's out. We're going to start swapping parts. So there's the seal. You can see is flipped, blown out, and that's why it's leaking so profusely. I don't think there's anything else we need off this. Oh, by the way, the crank sensor on the used engine was broken, so we have to take it out of the block. So this we can put off to the side. I've already drained the oil out of it. So the torque on these bolts, and you're supposed to put new bolts, is 22 foot-pounds plus 45 degrees. I found if you put a bolt through the flywheel, it'll stop it from turning, and it's easier, so you don't have to have somebody holding the crank bolt in the front. Again, we're going to put this oval hole up here. Avoid turning the engine backwards. It's not good for the timing chain guides. So I removed the broken crank sensor. Clean the oxidation off the block because it'll affect the air gap, and even though this is a Hall effect, sometimes the air gap creates a problem. So I'm going to put some silicone grease on that as well. So there's the bell housing back in, bolts back in. These larger bolts are torqued to 53 foot-pounds, and the smaller ones are 43. The torque converter bolts are 44, and put Loctite on them. Like I said, start with that oval ear there, you'll be able to get all the bolts in. All the bell housing bolts are in. It's pretty near impossible to torque those two bolts at the back because of access. So a couple ugga-duggas should be good. So there's an O2 sensor plug in place of the original O2. We'll clean up the gasket surface. We got the gasket on in the back with some high-tack spray. I gotta take this bolt out. So there's the bottom end all done. Starter in, crank sensor in, wiring harness in, battery cables, alternator on, AC compressor on, grounds hooked up, CV shaft reinstalled, bracket reinstalled, new bolt on the exhaust that I had to cut off, bell housing bolts torqued, everything done down here and everything done upstairs. So all we got to do now is put the air induction back together, put some oil and antifreeze in it, and fire it up. Well, we're about to start it up. Engine oil in it, coolant in it. Gonna have to burp the cooling system. Let's see if it starts. Okay, let's try and start this thing. Good. Uh-oh, what's going on there? It's obviously missing. Oh well. Too good to be true. Well, the check engine light is flashing. Let's see if it straightens out. So let's scan this thing and see what codes. It seems to have smoothed out. The check engine light has actually gone off now. But it was definitely misfiring, so maybe a piece of dirt got into the valve. 130,000 kilometers. D0300. Like I said, it's running smooth now. Cylinder 4, cylinder 3 history, cylinder 4 history. Well, let's clear it out because it's not misfiring now. Back in and look at misfire data. Yeah, we're good now. Let's watch the temperature here. So I'm going to run it up to temperature and fill the cooling system. Well, there it is, back together and running again. No warning lights on, cleared the codes. I don't know what was causing that misfire. Maybe a little piece of shit got in between the valve and the seat. But it showed 2 cylinders. But it's cleared up, it's running good. Cooling system full, washer bottle full. Engine oil I got to double check, but it should be good. I'm going to put it up in the air and have a look for any leaks. And put these plastic covers on underneath the hood here. And take it for a road test. Should be good to go. Thanks for watching. So I put a piece of 3/4 inch heater hose over top of that plastic tube to act as a insulator. I don't have any sponge insulation, but that's what I would recommend, is to pick up some of that 1/2 inch sponge insulation for water pipes, because if you can keep that tube from freezing, even if the system is malfunctioning and backs up into the air induction system, if it doesn't freeze, it won't blow the seal out.